Welcome to our poster. On this short occasion, I will present our poster, which was prepared by myself, Ikhwanul Muslimin, and my supervisor, Alexander Iskandar, from Physics of Magnetism and Photonic Research Division, Institut Teknologi Bandung, and my co-supervisor, Radius Suryadharma, from Metasurface Institute for Technology, University of Twente. For the first one, introduction. The use of electromagnetic waves, especially light, has developed rapidly in the world of science and technology. Light or optical signals have better prospects than electrical signals due to their almost unaffected nature by external electromagnetic fields. Conventionally, light manipulation is done using lenses, diffraction gratings, mirrors, and so on. The conventional technology has dimensions that are much larger than the wavelength of light. In its development, researchers are trying to design light technology with dimensions that are in the order of the wavelength of light, which is nanoscale. Next. Initially, resonance was always formulated with a Lorentzian model which has symmetrical shape without interference effects in the system. In 1961, Ugo Fano discovered a new type of resonance in the quantum system, which is now known as Fano resonance. This resonance has an asymmetrical shape, in contrast to the Lorentzian model, which has a symmetrical shape. Another type of resonance that has received much attention is electromagnetically induced transparency, or EIT, which can be considered as a special case of Fano resonance. Of this optical resonance phenomena, Fano resonance has received much attention until now, because its asymmetrical profile often shows sharp features. Fano resonance in a scattering structure is often explained by interference between a collective mode with a wide profile and another mode with a narrower profile. Through subsequent studies, now Fano resonance is understood as a result of interference between non-orthogonal modes in the structure. In this work, we investigate Fano profile of a metasurface consists of crescent-based structure from two different cylinders made of silicon on silica substrate. We arrange our structure periodically in square and hexagonal lattice with lattice constant of 300 nanometers with different radius of the first cylinder in each lattice, as shown here. We focus on the effect of variation of parameter delta, as shown in this figure, to the spectral response sharpness. Emphasis will be put on Fano resonance due to its sharper profile, which is characterized by gradient of the spectra response. We arrange our crescent structure periodically in a square and hexagonal lattice and compare the sharpness of the produced Fano profile as shown as in this figure. Left-hand figure is for hexagonal lattice and the right-hand figure is for square lattice. We run the simulation for unique delta as mentioned in the caption and the wavelength between 450 until 800 nanometers. As you can see here, both results shows Fano profile between 450 until 550 for hexagonal and 500 until 600 nanometers for square lattice. This one is Fano and this one is Fano. Because of the size of the lattice constant, we only consider zeroth order diffraction here. Furthermore, we vary delta to find delta value with the sharpest Fano profile for hexagonal lattice in this slide, as shown as in this figure. The top inset is the structure and the bottom inset is the Fano profile at a certain delta, shown by the black dot line here. So let's say this one. black dot line. We focus only in the range of wavelength where Fano profile occurred, so 450 until 550 as we said before. By plotting the gradient of reflectance against wavelength in nanometer and delta in R, we can find the sharpest Fano profile. Let's say, for example, on the right hand figure, the sharpest Fano profile is occurring around delta 1.2 and the wavelength around 540 until 560 nanometers. And for square lattice, as shown is in figure 6 here, unfortunately, we can see Fano resonance only for the bigger cylinder size, with the same information like previous slide. From here, we can see that the sharpest Fano profile is occurring around delta is around 0.43 and the wavelength between 550 until 560 nanometers. Okay, that's all from our poster. Thank you for visiting our poster.